In this lesson, we're going to introduce the use of polar equations. So far we've been working with equations with x and y coordinates. Well, now we're going to change to a different way to measure or locate a point on the coordinate plane. So, a polar coordinate is a way to locate a point using an angle and a distance. So if we start by taking a look at this, we've got this arrow here. We call this the polar axis here. So this arrow is pointing in the direction of the polar axis. And so if we start here, that's like a 0 radian angle. And we're going to rotate up a certain angle. And then we're going to travel out a certain distance. And the location of that point out there at the end will be measured by the distance and that angle. So if we're traveling an angle here of, let's say pi over 4 or 45 degrees, and maybe we're traveling out a distance of 5, then the location there would be 5 comma pi over 4. So it's measured by the r distance or the radius. If you think of this as a large circle that we're on here, all right, then that radius is a 5, and the angle is pi over 4. All right, so again, we call this the pole. The pole is the x, the positive x-axis here, and the origin is the same as always, this O here, all right? Okay. Actually, I'm sorry, the pole is the where the origin is, okay? And the polar axis is the x-axis there. All right. So the polar coordinates always are made of r and theta, okay? So the way we locate points is like this. Here we have the point 2 pi over 3. So we've rotated pi over 3 and we've traveled out to a distance of 2. So notice it's on this circle that has a circumference of 2, or I'm sorry, a radius of 2. If we have 3 and negative pi over 6, well, negative pi over 6 is traveling in the negative direction or the clockwise direction. And so we're going to turn, and then we're going to go out a distance of 3 there. So it looks like this. Again, we're rotating the negative pi over 6 direction, and we're going out to a radius of 3. All right, so let's look at one more. And actually, this one is wrong the way it's labeled. So let's go ahead and let's try negative 3, comma, 7 pi over 6. Negative. Let's do that. Negative, negative. There's a good one. Okay, so how do we deal with that? Well, let's get my little arrow thing over here if it'll cooperate. Okay, all right. Get my little arrow. All right, here we go. Okay, so what we're going to do is we're going to rotate around here to 7 pi over 6. Actually, that's going to be negative. So we're going to go rotate this way. Okay, going in the negative direction. There's 6 pi over 6, and 7 pi over 6 lands right over there. So that is negative 7 pi over 6 we just rotated. And now, what does it mean to have a radius of negative 3? Well, that means we're going to go backwards. So starting from the pole, we're going to go backwards 1, 2, 3. And that would be the point negative 3, negative 7 pi over 6. Right? Well, that's how we measure these angles or these points. We locate these points. Okay? And so there's actually lots of ways we can name the same point. So let's see if we can find a different equivalent polar expression for each one above here. Well, this one here we went to 2 pi over 3. Well, what if we went in the negative direction? What's that angle going all the way around there? Well, let's see. So this is pi over 3 less than a full turn. So I think our angle would be, a full turn would be 6 pi over 3. So this would be 5/3 pi, or 5 pi over 3. That's like 6/3 minus 1/3. and 2. So that would be like taking, going all the way around here, and then going out 2. So we're going to go negative 5 pi over 3 takes us around this way, and then we travel out 2, and we land on that point. So that would be the equivalent there. We could do the same thing here. This is, well, if we go in the positive direction, a full circle is 12/6 pi. So 12/6 minus 1/6 would be negative 11/6 pi. All right. So 3 comma 11/6 pi there. So yeah, that means if we're going to start here, and let's get our angle here. So if we go in the negative direction and then we travel out 3, we'll be landing in that same spot. So another way to name the same thing, all right? And let's see, what this one could be named. We could say this is 1/6 pi, negative, right? So this is negative pi over 6 as our angle. And again, it'd be positive 3. So another way we could get to this point here is if we take our arrow and let's put it, let's start here, okay? So if we take our arrow, we travel negative pi over 6 and then out a positive in the positive direction, we'll land there too. Okay, all right, well, there you have it, all right? Now, each of these has an x-coordinate as well. We could locate that x-coordinate. How do we locate that x-coordinate? Well, we're going to locate that by making some triangles. So if we take a triangle here, and we have the angle pi over 3 there, which is 60 degrees. Okay, and so we know that this hypotenuse is 2. This is our x, and this is our y. So let's see if we can find an equation for this. So we know that this, again, is pi over 3. So the cosine of pi over 3 is x over 2. If we solve that up, x is 2 times cosine pi over 3. And the cosine of pi over 3 is a half. So this is 2 times a half, which is 1. The y-coordinates, well, we can find that using sine. Sine is opposite over hypotenuse. So the sine of our angle here is opposite over hypotenuse, y over 2. So y is 2 times the sine of pi over 3. Well, the sine of pi over 3 is root 3 over 2, so this is 2 times root 3 over 2, which is root 3. Which means our coordinates of this point here in rectangular coordinates are 1 comma root 3. So we have polar coordinates and rectangular coordinates. Okay, so if you set this, if you got rid of the circles and just thought of this as the xy plane, then that's what your coordinate would be. Okay, so it turns out that we can do the same thing. Notice that we have here, we have x is the radius times the cosine of the angle. Y is the radius times the cosine of the angle. And those will be our formulas that we kind of see. We'll see them more specifically in a bit. Y is the r times the sine of theta. Okay? And that will get us all of our rectangular coordinates. So if we say x equals 3 times the cosine of negative pi over 6, well, the cosine of negative pi over 6, you can actually look at this here, okay? So the cosine of this angle is the long distance, root 3 over 2. So this is 2 times root 3 over 2, which is 3 root 3 over 2. The y-coordinate is going to be this sine, which is negative a half, so it'll be 3 times the sine of negative pi over 2, pi over 6. Sorry, so that's 3 times negative a half. Thinking about your unit circle, it's the short distance in the 30, 60, 90, and it's going down. So 3 times negative a half would be negative 3 halves. So our rectangular coordinates here would be 3 root 3 over 2 and negative 3 over 2. And those are rectangular. Polar coordinates given to us here. Here's another version of polar coordinates. And the rectangular coordinates are in the box there. One more. Okay. Well, it doesn't matter which one we use here. Same idea is going to apply. All right. So we have, let's erase this here. All right. So here we're traveling. Where are we traveling here? So we got 11 pi over 6. Actually, well, it's going to be the same thing, right? Okay, notice it's the same spot. So we're going to end up with the same rectangular coordinates. Okay. 3 root 3 over 2 and negative 3 over 2. All right. So we have multiple ways of locating a point or naming a point. So that's going to be important because we're going to kind of come back to it, and that has to do with the cyclical nature of trig functions, which we'll be using a lot of. Okay, so why polar coordinates? Well, a lot of things travel in this repeating motion, okay? And rather than describing things in rectangular equations, it's going to turn out to be easier to represent them as with these trig functions especially. And we get this spiral or rotational kind of pattern going on. So let's see how that works. So here we got a bunch of graphs. Now, we'll do a few by hand, but once we get the hang of it, we'll let our calculator do the work. We'll see what's going on, okay? Now, as we do this, all right, it's going to be useful to kind of remember your unit circle. So your unit circle, in your unit circle, now notice this, radius equals 1 is the unit circle, okay? So we can remember this as root 3 over 2, 1/2, because we're going long distance, short distance there. Pi over 3 is going to be 1/2 root 3 over 2. Okay, let's see, sine and cosine here. This is going to be negative 1/2 root 3 over 2. And we have negative root 3 over 2, positive 1/2. We've got negative root 3 over 2 for cosine, negative 1/2 for sine, and we have negative 1/2, negative root 3 over 2. We have, I'm skipping the 90s because they're pretty straightforward, zeros and ones. And we have 1/2 negative root 3 over 2. And root 3 over 2 and 1/2. Now, we're going to be doing some graphing. So another thing that's kind of useful here is if we have some decimal values. So 1/2 is obviously 0.5. Root 3 over 2 is 0.8660. And we'll run into root 2 over 2, and that is 0.7071. So those are kind of useful to know as we do this using these different angles. Okay, so what does that mean? Well, we're going to graph, let's graph the cosine of theta. R equals the cosine of theta. So what we're going to do is we're going to think about what angle we're looking at here. And then, let's see here. Let's try this again. So we got our arrow here. Okay, so we're going to think about what angle we're looking at, and that will decide how far we're going to go. Now, this is going to be a pretty small one here, all right, because this is 1 cosine, all right, so it's going to be pretty close here, all right, so we're going to turn there here, okay, and we're looking at the cosine, so we're just talking the cosines here at this time, all right, so the cosine of this angle, let me go ahead and get rid of that there. Okay, so the cosine of our angle is, cosine of 0 is 1. Then we have root 3 over 2, which we said was 0.8. About 80% of the way there, maybe a little closer, 0.8. And then we have 0.7. And then we have the cosine of 0. So when we're looking up at this way, so that's a pi over 2, the cosine of pi over 2 is 0. And then the cosine, when we're looking out this way, is negative 1/2. So we're looking out that way. The cosine is negative 1/2, which is back here. Okay, and then we're looking out this way, and the cosine is, let's see, this one was supposed to be 1/2 there. All right, when we're looking out this way to 5 pi over 6, then our cosine is negative root 3 over 2. That means we're looking backwards at 0.8660. That's right here. Okay, and then when we're looking out this way, okay, so let's cross that. So when our arrow is looking out this way, well, our cosine is negative 1. This is negative 1 comma 0. So the cosine is negative 1. Well, that's right back over here. And then when we're looking this way, okay, so if we turn and look this way at 7 pi over 6, we're going to travel. Our cosine is negative root 3 over 2, or negative 0.8660. Well, that puts us backwards right here. See how we're repeating? And now when we're looking down here, so we turn, we're looking down this angle down here at 4 pi over 3. Well, the cosine is negative 1/2. So we're going to go back here, and we're going to land right at 1/2. We were at positive 1/2 last time. Okay? And we're going to keep going around and around in circles like that. Okay? And it's just all going to repeat. So when we're looking straight down, the cosine is, this is 0, negative 1. So the cosine is 0, the x-coordinate there. Okay? Again, these coordinates I'm putting are the unit circle coordinates. So what does that look like? Well, what's going on here? Well, it ends up being a circle. Not a very good circle there, but that's supposed to be a circle. Okay? Interesting. Well, what happens when we have 3 cosine? Well, when we're looking out this direction, we're going to go 3 times as far. When we are looking out this direction, the cosine of pi over 6 is root 3 over 2, or 0.8660. And we're going to triple that, 0.86 times 3. Well, let's see. 0.8 times 3 is 2.4. 0.8660 is going to be a little beyond that, okay? So, all right. Okay. And if we're looking out here, we have the cosine of pi over 3 is 1/2. We're going to triple that. 3 times 1/2 is 1.5. Then when we're looking this direction at pi over 2, cosine is 0. And then we're looking out this way here, and the cosine is negative 1/2 times 3 is 1.5. And then we got about 2.5-ish. Okay, 3 times that. And it's going to end up being a circle that's just 3 times as large. Okay, so it's going to be a circle with a diameter of 3. This one down here had a circle with a diameter of 1. Okay. All right, well, what happens for sine? Okay, so let's go through it here. Okay, now we're going to have 2 sine times theta here. Okay, so we're thinking about sine. We're thinking about the y-coordinates of the unit circle. Okay, so in the 0 direction, the sine is 0. So when we're looking out this way, the sine is 0. So our point will be 0. When we're looking out this way, the sine in that direction is 1/2. We're going to double that because we're doing 2 sine. 1/2 doubled is 1. When we're looking this way, the sine is root 3 over 2, or 0.8660. If we double that, we get 1.7 about. Root 3, okay, is what it is. Okay, so about 1.7. When we're looking straight up, the sine is 1. And when we double 1, we get 2. When we're looking out here, the sine is, again, root 3, which is 1.7. Looking out here, the sine is 0.5. So that is double that, 1, because we're doing 2 sine here. We're looking out here, the sine is 0. So pointing that direction, the point ends up right back here. And then it's going to repeat. When we're looking down here, the sign is negative 1/2. Negative 1/2 doubled puts us right there. Okay? So we're right back where we started. Now when we're looking down this way, the sign is negative root 3 over 2. Doubled is negative root 3. We end up right there. Okay? So we end up just repeating. So we get a circle again. And there's our circle. So the sine circle goes up towards the y direction. The cosine circle is going to go off in the x direction. Not a big surprise. Okay? The rest of these we can kind of graph on our calculator. Well, what do you think is going to happen for negative 2 sine? Okay, well, that's going to go down, right? So we're going to go down, and we'll be like this. So we circle with a diameter of 2, but everything's going to flip the opposite direction. Okay. What if we have 2 plus 2 sine? All right, let's do this one here and see how this is a little different. Well, if we take each of these and we double them, we add 2. So we're going to add 2. Okay. So we're going to take this distance of, what is that, 1, and we add 2, we get 3. Oh, I guess we should say this first. Okay, so 0, looking out in this direction, 2 sine of 0 is 0, plus 2 is 2. Okay. Then we have in this direction, we had, what do we have? We had 1.7. 1.7 plus 2 is 3.7. So 3.7 is what we'll land at up here, okay? And then up here, if we add 2, we end up top, okay? And out this direction, we were at 1.7. We're going to add 2, we get 3.7. In the 5 pi over 6 direction, we had 1. We're going to add 2, and that gives us 3. What's wrong with this picture? Yeah, that's right. Okay. And then we have going in the left direction, the sign is 0, but we add 2. So we're looking out this way. That's our angle. Angle is pi. And we're going to go 0, because the sine of pi is 0, times 2, which is 0, plus 2, which is 2. So we're going to be out at 2 again. Okay, so far, we kind of have this circle look. But watch what happens now. All right, we're pointing down at 7 pi over 6. If you plug in 7 pi over 6, the sign is negative 1/2. Times 2 is 1. Negative 1, that is. Negative 1 plus 2 is going to give us positive 1. Now we're looking down in this direction. The sign is negative 0.86. Okay. If we double it, we get that 1.7. Negative 1.7 plus 2. Negative 1.7 plus 2 is going to give us negative 0.3. Okay. Now we're looking down here. And when we plug in pi over 2, the sign is negative 1. Negative 1 plus 2 is negative 2. Negative 2 plus 2 is going to give us 0. Interesting. Over here, okay, the sign is negative pi, root 3 over 2, doubled, it's negative root 3, 1.7. Negative 1.7 plus 2 is negative 0.3, something down here. And we're almost there. Looking over here, 11 pi over 6. Well, the sign there is negative 1/2. Negative 1/2 times 2 is negative 1. Negative 1 plus 2 is a positive 1. So we're going to be out at positive 1. So we have this symmetry left and right. But we get this shape right here that looks kind of like a heart upside down. And this is what we call a cardioid. Okay. Kind of interesting. Okay. Well, the rest of these, go ahead and graph them on your calculator and watch what happens. Now that we've kind of cranked through these, graph them and you'll see what happens. And we'll see the relationship between the numbers that we add and the numbers that we multiply. If you want, you can actually graph them on Desmos. That might be a little easier. You graph it on your calculator, change the mode to polar. It works, but for exploration, it might be easier to graph on Desmos. And when you do, you'll get something like this. Now, these are hand-drawn. Your Desmos calculator will show you a lot better. But we get some interesting things. Notice when we added here, let's see, come on back here. Okay, so notice when we added this 2, that circle kind of came underneath here, all right? And it got this little bubble there, okay? But when we only add 1, well, we get interesting. Now, this is cosine, so it's going to the right. This is sine, so it was going up, okay? But we only added 1, so it ends up getting this little loop here. Kind of interesting, all right? And some idea if we have 2 plus 1, all right, then we're going to get this kind of circle-y here. It's not exactly a circle. It's kind of flat on one side. Same one repeated there. What happens when we throw numbers in, multiplying inside the cosine? Well, we end up getting what we call petals. So this has 4 petals for cosine of 2 theta. If we have 3 times cosine 2 theta, we get the same look. They just go out to 3. We might expect that. Okay. If we have 2 sine 5 theta, well, it goes out to 2, so that's like an amplitude thing. We should expect that. And we get 5 petals. So by multiplying on the inside, we end up with these petals. All right. And there's a lot that can be discovered. Go change that number, and you'll see pretty quickly what happens with the petals.